A voltage drop calculator is a tool used to determine the amount of voltage loss that occurs in an electrical circuit due to the impedance of the conductors. Voltage drop is an important consideration in electrical design, as excessive voltage drop can cause equipment to malfunction or operate inefficiently. There are several online voltage drop calculators available. Firstly, VD Calculator. Net offers a straightforward voltage drop calculator. Secondly, Calculus. OG provides a voltage drop calculator as part of its suite of calculus applications. Thirdly, Symbolab. Com offers a voltage drop calculator for mathematical computations. Furthermore, the integral and derivative calculator at Integral Calculator. Com includes voltage drop calculation capabilities. In addition to online calculators, several software packages offer voltage drop calculation capabilities. Wolfram Mathematica is a powerful computational software that can be used for a wide range of mathematical and engineering calculations, including voltage drop calculations. Maple is another software package that offers similar capabilities. MATLAB is a widely used software in engineering and science for numerical computation and simulation, and it includes tools for voltage drop analysis. Scilab is an open-source software package that provides a platform for numerical computation and simulation, and it can be used for voltage drop calculations. Furthermore, there are additional resources available to help you understand voltage drop and how to calculate it. The Voltage Drop Calculator Guide at Integral Calculator. Com provides a comprehensive explanation of voltage drop calculations. Khan Academy offers resources on understanding voltage drop and its applications. Voltage drop calculations are essential for ensuring that electrical systems operate safely and efficiently. By using the available online calculators, software packages, and resources, electrical engineers and technicians can accurately determine voltage drop and design systems that meet the required performance standards. When performing voltage drop calculations, several factors need to be considered, including the conductor material, length, and cross-sectional area, as well as the current flowing through the conductor. The voltage drop is directly proportional to the conductor length and current, and inversely proportional to the conductor cross-sectional area. Different conductor materials have different resistivities, which affect the voltage drop. Copper and aluminum are commonly used conductor materials, with copper having lower resistivity than aluminum. The allowable voltage drop in a circuit is typically specified by electrical codes and standards. The National Electrical Code, or NEC, provides guidelines for voltage drop in branch circuits and feeders. Exceeding the allowable voltage drop can result in reduced equipment performance, overheating, and potential safety hazards. Voltage drop calculations are also important for determining the appropriate conductor size for a given application. Using larger conductors can reduce voltage drop, but it also increases the cost of the installation. Therefore, it is important to balance the cost of the conductors with the need to maintain acceptable voltage drop levels. In addition to conductor impedance, other factors can contribute to voltage drop in a circuit, such as connections, splices, and terminations. These connections can introduce additional resistance, which can increase voltage drop. It is important to ensure that all connections are properly made and tightened to minimize resistance. Voltage drop calculations can be performed using various methods, including Ohm's law, the voltage divider rule, and specialized software tools. Ohm's law states that the voltage drop across a conductor is equal to the current flowing through the conductor multiplied by the conductor's resistance. The voltage divider rule can be used to calculate the voltage drop across a portion of a circuit if the total voltage and the resistance of each component are known. Software tools typically use more complex algorithms to account for various factors that affect voltage drop, such as temperature, conductor bundling, and proximity effects. When using voltage drop calculators or software, it is important to ensure that the input parameters are accurate and that the results are properly interpreted. Misinterpreting the results can lead to incorrect design decisions and potential problems with the electrical system. Voltage drop calculations are an integral part of electrical design and should be performed for all circuits to ensure that they meet the required performance and safety standards. By understanding the principles of voltage drop and using the available tools and resources, electrical engineers and technicians can design reliable and efficient electrical systems. The process of calculating voltage drop involves several steps. Firstly, determine the load current. This is the amount of current that the circuit is expected to carry under normal operating conditions. The load current can be calculated by dividing the load power in watts by the voltage of the circuit. Secondly, determine the conductor length. This is the total length of the conductor from the source to the load and back. The conductor length should be measured accurately to ensure that the voltage drop calculation is correct. Thirdly, determine the conductor size and material. The conductor size is typically expressed in terms of its American Y gauge or Ogg rating. The conductor material is typically copper or aluminum. The conductor size and material affect the conductor's resistance, which in turn affects the voltage drop. Fourthly, determine the conductor temperature. The conductor temperature affects the conductor's resistance. The resistance of a conductor increases with temperature. The conductor temperature can be estimated based on the ambient temperature and the load current. Fifthly, determine the allowable voltage drop. The allowable voltage drop is typically specified by electrical codes and standards. The NEC recommends that the voltage drop in branch circuits should not exceed 3% and that the voltage drop in feeders should not exceed 5%. Sixthly, calculate the voltage drop. The voltage drop can be calculated using Ohm's law or specialized software tools. Ohm's law states that the voltage drop is equal to the current multiplied by the resistance. Seventhly, compare the calculated voltage drop to the allowable voltage drop. If the calculated voltage drop exceeds the allowable voltage drop, then the conductor size must be increased or other measures must be taken to reduce the voltage drop. Several factors can affect the accuracy of voltage drop calculations. These factors include the accuracy of the input parameters, the complexity of the circuit, and the limitations of the calculation method. It is important to use accurate input parameters and to choose a calculation method that is appropriate for the complexity of the circuit. Voltage drop calculations are particularly important in long circuits, such as those found in industrial plants and commercial buildings. In long circuits, the voltage drop can be significant, and it is important to ensure that the equipment at the end of the circuit receives the required voltage. Voltage drop calculations are also important in circuits that supply sensitive electronic equipment. Sensitive electronic equipment can be damaged by excessive voltage drop. Therefore, it is important to ensure that the voltage drop in these circuits is within acceptable limits. In addition to calculating voltage drop, it is also important to consider voltage regulation. Voltage regulation is the ability of a power source to maintain a constant voltage under varying load conditions. Poor voltage regulation can cause voltage fluctuations, which can damage equipment and disrupt operations. Voltage regulation can be improved by using voltage regulators or by increasing the size of the conductors. Voltage drop and voltage regulation are both important considerations in electrical design. By carefully considering these factors, electrical engineers and technicians can design electrical systems that are safe, reliable, and efficient. Furthermore, it is important to understand the impact of harmonics on voltage drop. Harmonics are sinusoidal currents or voltages having frequencies that are integer multiples of the fundamental frequency. They can distort the voltage and current waveforms, leading to increased voltage drop and heating in electrical systems. Nonlinear loads, such as electronic devices and variable frequency drives, are common sources of harmonics. To mitigate the effects of harmonics, harmonic filters can be used to reduce the harmonic content in the system. Additionally, using appropriately sized conductors and transformers can help minimize the impact of harmonics on voltage drop. Power factor correction is another important aspect to consider in relation to voltage drop. Power factor is the ratio of real power to apparent power in an electrical circuit. A low power factor indicates that a significant portion of the current is reactive, which does not contribute to useful work but still causes voltage drop in the conductors. Improving the power factor by using capacitors can reduce the reactive current, thereby reducing voltage drop and improving the efficiency of the electrical system. Transients and surges can also cause voltage drops in electrical systems. Transients are short-duration voltage or current spikes, while surges are longer-duration over-voltage events. These events can cause temporary voltage drops that can disrupt the operation of sensitive equipment. Surge protection devices, or SPDs, can be used to protect equipment from transients and surges, helping to minimize voltage drops and prevent damage. When designing electrical systems, it is important to consider the potential for future load growth. As new equipment is added to the system, the load current will increase, which can lead to increased voltage drop. To accommodate future load growth, it is advisable to use larger conductors or to design this system with extra capacity. Regular maintenance and inspection of electrical systems are essential for preventing voltage drop problems. Loose connections, corroded conductors, and damaged insulation can all contribute to increased voltage drop. Regular inspections can identify these problems early, allowing for timely repairs and preventing more serious issues. In addition to the factors mentioned above, the grounding system can also affect voltage drop. A properly designed and installed grounding system can help minimize voltage drop by providing a lower impedance path for fault currents. This can help prevent voltage dips during fault conditions, protecting equipment and ensuring safety. The use of renewable energy sources, such as solar and wind power, can also impact voltage drop. These sources often have variable output, which can cause voltage fluctuations and voltage drop problems. To mitigate these issues, it is important to carefully design the integration of renewable energy sources into the electrical system, using appropriate control and protection devices. In summary, voltage drop is a critical consideration in electrical design and operation. Accurately calculating voltage drop and implementing appropriate mitigation measures can help ensure the safety, reliability, and efficiency of electrical systems. By using the available online calculators, software packages, and resources, electrical engineers and technicians can effectively manage voltage drop and design robust electrical systems. Remember that voltage drop calculations should be performed for all circuits to ensure that they meet the required performance and safety standards. Furthermore, it is vital to stay informed about the latest industry standards and best practices related to voltage drop and electrical system design. Continuous learning and professional development can help electrical engineers and technicians stay up to date with the latest technologies and techniques for managing voltage drop and ensuring the optimal performance of electrical systems. Always consult with qualified professionals and adhere to all applicable codes and regulations when designing and installing electrical systems. Ignoring voltage drop considerations can lead to serious consequences, including equipment damage, safety hazards, and inefficient operation. Therefore, it is essential to prioritize voltage drop management in all electrical projects. By following these guidelines and using the available resources, you can effectively manage voltage drop and contribute to the design of safe, reliable, and efficient electrical systems. When working with electrical systems, safety should always be the top priority. Never attempt to work on energized equipment unless you are properly trained and qualified. Always use appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and arc-rated clothing. Be aware of the potential hazards associated with electrical work, such as electric shock, arc flash, and arc blast. Follow safe work practices and procedures to minimize the risk of injury. Remember that electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. In addition to safety, it is also important to consider the environmental impact of electrical systems. Choose energy-efficient equipment and design systems that minimize energy waste. Promote sustainable practices and reduce the carbon footprint of electrical installations. By considering both safety and environmental factors, you can contribute to a more sustainable and responsible future. Voltage drop is not just a technical issue, it also has economic implications. Excessive voltage drop can lead to increased energy consumption, reduced equipment lifespan, and higher operating costs. By minimizing voltage drop, you can improve the efficiency of electrical systems and reduce their overall cost. Therefore, voltage drop management is not only a matter of safety and reliability, but also a matter of economic sustainability. In conclusion, voltage drop is a multifaceted issue that requires careful consideration and management. By understanding the principles of voltage drop, using the available tools and resources, and prioritizing safety and sustainability, you can contribute to the design of electrical systems that are safe, reliable, efficient, and environmentally responsible. Always remember to stay informed, follow best practices, and consult with qualified professionals to ensure the success of your electrical projects.